Hello everyone and welcome to Lab 10. Lab 10 is about working more with images, and today we're going to try to work with a problem, a barcode retrieval. A barcode is just this kind of image with a lot of bars, one white and black or black and white, that has some numbers. Those that you use at the supermarket or groceries that you can scan, and from there you get a number and then a price or something like that. Our job today is design a program that can read and detect this kind of barcode. For that, I have to mention that we are going to be using functions. We've been using functions since week 5, but you've been a user so far. For example, functions from MATLAB are the sprint, square root, imshow, and so on. Basically, a function can be created with the word function, listing the output variables that you expect from that specific function, and then the name of the function with the input parameters that you want, and inside is the code. Why I am mentioning this? Because in this lab we are going to be using a helper function called BarCodeLookUpTable, where we're going to pass a parameter, the width of the a list of the width of the bars into that, and that function will give us the right barcode in the end. So for example, here we got this image that has a lot of bars. Our job is it is two-part. Basically, we need to form the 12 digits like this one, but we don't know, once the image is given to you, you don't know those numbers. So what we do, or the process to get those numbers, is to measure the width of each column, the white and the black, from the image. And the most important one is the first, because we need to normalize with the first one as a reference. So from there, what's going to happen is that we're going to have 59 numbers after normalization, but we're going to skip or avoid the first 3, the last 3, and the 5 numbers in the middle, and that's what we keep. So in the end, we're going to have 48 numbers that are passed through the lookup table, and then we get the final result. Our job is to get these 48 numbers. That's our expectation. Let's say, for example, that we have this image like this one. I'm rotating it so you can see. For example, let's imagine that all these pixels, or all these columns, are 10 pixels. The width is 10 pixels for the first 1, 2, 3, 4, 5, 6. So, and then the next one is 40. Those ones there are 10 pixels. The big white column is 30, 20 pixels, and so on. So what's going to happen is that we're going to divide all those width for the number 1, normalizing. So even including the number 1, we're going to have 10 divided by 1 is going to be 10. The next 5 width, it will be, everything is 10 divided by 10, so it will be 1, 1, 1, 1, 6, 1. Remember that we're going to skip or avoid the first 3, and then if we keep dividing, we keep getting numbers. We're going to have then something like this, 1, 1, 1, and then the 40 pixels, that will be a 4. Then 10 pixels, that will be 1, 1, and then we get 3, 2, 3, 2, 1 respectively. So what we do is that we group everything in groups of 4, like 1, 1, 1, 4. We got the line, and then we got 1, 1, 3, 2, then we got this, and so on. We had to do it for the whole image. And then there is a lookup table that you can get, depending the sequence, you can guess the numbers if it is 0, 1, 2, 3, 4. So the function, the function that we use, it is in charge of looking for those numbers. That's not our job. Our job is measuring the width of each column and getting these numbers, the 1, 1, 1, 4, and so on. So here, for example, for the we got these numbers that we got here. The third one is 3211. That will be the number 0. We got 11114. This one here on the top, that's the number 6, and 1132 is the number 4. So these three numbers in sequence, those will be equivalent to 640. Those are the ones that we got here. So if you get the idea, that's what we're going to do. Remember that black is 0 and 255 is white. But when you are working with images, real images, probably you need to work with numbers in between. Don't expect the black to be 0, plain 0. It might be some gray, so probably it will be 7, it will be 10, it will be 20, it will be in a small number. So probably you need to get a threshold, not just 0 or 255. For the 255, you can expect something like 240, 242. You need to test with that. Let me go back to the Canvas page. Sorry about this. So here we are in week 11, lab 10. For this week, we have activities and attendance. For the activities, well, you can look at the document, but we have two parts for the problems today. The part 2 is the universal barcode reader. That's pretty much what I explained in the presentation. But for this first problem, so you can start like step by step the first part of the final program, you need to get the edge. You need to start from the left side, if your code works like that, until you detect the first black column. So in this case specific, with the test case that is given is barcode 1, the index of the left edge is 2. Why is that? I'm going to, if I open this image here, I have it open already. So what happens is that when you open it, you don't know when the bars start. If you start looking at the first row, probably you will never get any black color. So probably you want to start in the middle, something knowing row 0, in some row that you know that there is a black. That's if you start from left to right. And then you don't want to start all here in the white space, so you need to start counting to see, just to check where is that the first black occurs. So you need to check for that specific column. That's important, and that's what we're doing in the first part. Lastly, let me see what else I got here. This is the final problem. You have two test cases. You have barcode 1, barcode 2, and those are the numbers resultant numbers that you get. Here, the template, you see that you need to get the code. You need to type your code here, and then once you get the result in width, you don't have to worry to decode. What you want to pass here in width is a vector that has all the numbers 1, 2, 3, 4, whatever the widths are, normalized to the first column. I hope that that's helpful for you, and that you can work with both the peer mentors today. And next week we're going to be working with a more challenging problem and see if we can have some fun with that. Going back to our Canvas shelf, we are very close to the end of the semester. This is the more challenging one. I've been pushing this. Lab 12 is preparation for the exam holiday, and that's it. Functions, and the semester is over. I see you in person next week, and I will try my best to be online as well. See you guys.